Hello folks, you have a quiz tomorrow, so this is your review, or actually maybe it's today if you're just watching it during class. We are preparing for our linear functions review. Let's start right on at number 1. Decide whether each function is linear or non-linear. There are multiple ways in which you can go about doing this. For starters, if you look at your equation, you realize, there are no exponents larger than 1. Like in number 2, you can see the x is squared here. We don't see any big exponents, so that's a good indicator that it could be linear. But let's prove it. Let's see how we can tell for sure. First things first, we know two forms of linear equations that we've talked about in our workbook this week. The first form is y equals mx. Remember, m is just your rate of change. And the second form is y equals mx plus b. B is just your initial value. These two are really the same form. It's just in this first form, the initial value happens to be 0. In this form right here, your initial value is something other than 0. That's why this b is here. Anyways, let's put equation 1 into this second form right here, because that's what it looks like that's going to happen. Let's solve for y. Let's isolate y. In order to do that, we have to get rid of this 3. We have to take it to the other side. So let's subtract 3 from both sides. That leaves us with y is equal to 5x minus 3. Keep in mind, you can't combine the 5x and the 3 because they are not like terms. So I'm going to rewrite this. I like seeing the y on the left-hand side. 5x minus 3. Now look, this guy right here, he's in this form right here. And we have already talked about several times this week that any equation that's written in y equals mx plus b form is definitely linear. So the answer is linear. If you wanted to go one step further, you could create an xy chart, a table, just like you're seeing in questions 3 and 4. Choose a couple numbers to plug in for x. Plug them in, and you'll find out that, in fact, the rate of change is constant, and this is a linear function. Let's go on to 2. Number 2 is definitely nonlinear for a couple of reasons. You could either recognize that there's an exponent of 2 here on your x, or you can do the same thing that we could have done in 1. We can create a table. That's what I'm going to do for this example. So if we create a table, we get to choose our input values, our x values. So I'm going to choose -1, 0, and 1. And I'm going to do these one at a time. So let's start with x equals -1. If it equals -1, we're going to plug it in place of x. So if I'm plugging it in, it's going to look like this. Y equals 7 plus, now we're plugging -1 in for x, and it's got to be squared. So -1 squared is just +1. You've got to add it to 7, and you realize that when x is -1, y equals 8. Well, let's figure out these other ones. Sorry, I'm showing my work in random places, but that's because I only have so much space. So let's plug in 0 now. Y equals 7 plus 0 squared. Well, that's really just 0, so y equals 7. Now let's plug in 1. Okay, let's plug in 1. Y equals 7 plus 1 squared. Well, what's 1 times 1? It's 1. So 7 plus 1 is 8. So this is 1, 8. Okay, don't be misled here, folks. If you're looking for the rate of change, you notice that our x's only change by +1. They go up by 1. That's a good sign, but when you come over to the y's, you should notice something strange. They go down 1, and then they go back up 1. So if you're looking to find the rate of change of this function, initially it looks like it's -1, and then it changes to +1. So what you're seeing is that the rate of change is not constant. Therefore, this function is non-linear. If you graphed this thing, it would make some sort of U shape, okay? So it would definitely be non-linear. Let's go on to 3 here. If we're looking to find out if this guy has a constant rate of change, let's figure out the change in our y values, or our vertical change. Looks like it's +5 all the way through. +5, +5, +5, and +5. And our horizontal change looks like it's a simple +1 every time. So our rate of change seems to be constant. Our rate of change is 5/1, or just 5. Since we have a constant rate of change, this function is in fact linear. So that's the answer to 3. Moving on to 4, let's do the same thing. We want to find out if this represents a linear function. So to find the rate of change, let's start with our y values. Our vertical change, -1, -2, -4, -8. All right. Let's look at our horizontal change. It looks like it's +1. +1, +1. Looks like it's +1 every time. So our rate of change does not stay the same throughout. So that's why this guy is considered nonlinear. Once again, if you graphed this guy, it would not form a straight line. On to question 5. As you can see, our function is right here, this nice U shape. We call this a parabola. It should probably have arrows on it right here. And this guy's obviously not linear. Okay, it does not form a straight line. So this guy is non-linear. Let's keep going on to number 6. As you can see, this function is a straight line. The graph of our function is a straight line. So this one's pretty simple. It is linear. There is a constant rate of change. Those ones are pretty straightforward. Now let's go on to 7. Dudered Taxi Company charges passengers $5 for a ride and an additional $1.50, I guess I should have circled all of this, for each mile traveled. Mr. Dudek says that he can model the cost with a linear function. Explain whether or not Mr. Dudek is correct. Chances are you're going to get credit if you just write Mr. Dudek is always correct, because that's hard for me to argue. However, I would like proof. So, I need you to look at what information you're given and think. Do we have an initial value? Well, if someone decides to take Dudered Taxi Company and they step foot in the taxi, they're going to have to pay $5 before they go anywhere. So your initial payment, or your upfront cost, is $5. Then, if you go 1 mile, you're going to pay $1.50 more. If you go 2 miles, you're going to pay $1.50 plus $1.50, or $3 more. If you go 3 miles, you're going to pay $1.50 plus $1.50 plus $1.50 more, or $9.50. So what you're seeing is we have a constant rate of change. For every mile that you go, you're going to pay $1.50 more. So we know from our template how to write an equation. We always say y is equal to the initial value, which in this case is $5, plus our rate of change, $1.50 or 1.5, times x. X represents number of miles traveled. This is, in fact, a linear function. It represents our situation. So Mr. Dudek is correct, since we have an initial value and a constant rate of change. All right, folks, I'm going to put out another video with questions 8 through 10.